Distance. A point's location on a line is described by its coordinate. The coordinate, or the xy, tells you where it is located. That is the ordered pair. Coordinates, xy. Measure along the reference points. Like if the origin, that is 0, 0. You have the x-axis, the y-axis. The cart is in plane. Named for Rene Descartes, who we read a little bit about last week, I believe. First mathematician. So, first mathematician to connect geometric figures and algebraic equations. So, the cart is in plane is named after him from his last name. All right. So the first thing we look at is finding the distance. Now, finding the distance between 2 points on just the number line is very simple, right? You do what you did in your bell work. You just subtract and take the absolute value. You're literally just saying from this point to that point on a number line, very simple. But when you throw it on the coordinate plane here, then all of a sudden it's not as simple as that, because you have this angular measure that starts happening. And it's not just as simple as 2 points. You now have 4 numbers involved, not 2. And so we actually use what's called the distance formula. It is based on the Pythagorean theorem. All right, the distance formula is based on the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So you'll notice they have the point A and the point B. I want to find the distance between point A and point B. In a right triangle, this guy is the hypotenuse, which we did a little bit of this last year. A squared plus b squared equals c squared. We know that from a right triangle. So then in this case, what is a squared? Well, a squared is the distance from this x to this x, right? And then b squared would be the distance from b would be the distance from this y to this y. So then the distance between these two is the square root of those added together, okay? And so they get the distance formula from the Pythagorean theorem. The distance formula then says you're going to take the square root of the difference of your x's squared plus the difference of your y's squared. All right, a squared plus b squared equals c squared. You take the square root of both sides to find c. So that is your distance formula. You just subtract your x's and square it, subtract your y's and square it, add those two together, and then take the square root. That is your distance formula. x1 minus x2 squared plus y1 minus y2 squared, quantity square root of that. All right, it does not matter what order you subtract in. The reason it doesn't matter what order you subtract in is you are squaring the group. So if you say 5 minus 2 and you get 3, and then you square it, you will get 9. If you say 2 minus 5 and you get negative 3, and then you square it, you will get 9. So it actually does not matter what order you subtract in. It matters that you subtract and then square, subtract and then square. You have to do order of operations here. All right? So let's look at using the distance formula. Find the distance between these points. All right, so my distance formula, it is distance equals the square root of my x's subtracted and squared and my y's subtracted and squared. So that's what I'm going to do. I'm going to just plug it in. If I'm finding my distance, I'm going to say my x's, negative 2 minus 4 squared. Plus, you are always adding in between the groups. And then your y's, 5 minus 1 squared. So what is negative 2 minus 4? Negative 6. And 5 minus 1 is 4. When you square something, it will always be positive. Now, here's the deal. You're using calculators. I will say if you put it into your calculator and you say negative 6, and then you hit your little squared button, it's going to give you negative 36. And the reason it's going to do that is because negative 6 squared is different than negative 6 squared like that. Okay? In your calculator is doing order of operations, and your calculator looks at it like this versus this. All right? So your calculator will square your 6 and then apply your negative if you do not put parentheses. I'm telling you this so that if you're going to be using your calculator, you don't want to get it wrong just because you did not know how to use your calculator correctly. So when you put a negative in to square it in your calculator, you want to use parentheses there. All right? So negative 6 squared then is positive 36. 4 squared is 16. What's 36 plus my 16? 52. Thank you. All right. So now here's the deal. There's two ways that you will get, it will ask for an answer. One way it'll say exact. Exact means I want you to just simplify your radical. We did this last year. We're going to review it. The other way it will say round, which means put it into your calculator and give me a decimal. Okay? So if it says exact, then you are going to take this 52 and you are going to use your factor tree here. We're taking the square root. Remember, if it pairs up, it comes out. If it doesn't have a pair, it stays in. So 2's pair up. There's 2 of them. That comes out. That's a 13, not a 3. And then the 13 does not have a pair, so it stays in the root. That would be the exact answer. If it said, give me the exact distance, that is what it is looking for. 2 squared of 13 is the exact distance. If it says round, then you are going to plug it into your calculator and you're going to round to the nearest whatever it says. Round to the nearest tenth. When you put that into a calculator, you would get 3.61. So if I said round to the nearest tenth, your answer would be 3.6. So pay attention to your instructions if they want it exact or if they want it rounded. All right, that's the difference in those answers. The next formula we're going to look at is midpoint. Once again, on a number line, finding the midpoint is just a matter of averaging your two numbers. If you are looking at the midpoint between -4 and 5, you're just going to add those up and divide. You're just going to average what's in the middle of those two. But now you have two different points because it is a coordinate. It is an x, y. All right? And so basically all you do for your midpoint is you average your x's and you average your y's. And that is your midpoint. So in this case, you're not subtracting, you're actually adding your two x's and dividing by 2, and you're adding your two y's and dividing by 2. You're literally finding the average between the x's, the average between the y's, and that will be the midpoint of the line segment that you've been given. And you can see the figure here. We have A to B. If I were to take my x's and find the average, I'm going to get right here, and then find the y's, I'm going to get right here, and that's going to give me my new point. So let's look at actually using it. Example 2, find the coordinates of the midpoint given x and given y. You're simply going to add them up. Your answer, however, will be a point, okay? Your answer will be a point, not like a length. So for your x's, you would say -2 plus 1 over 2. And then you would say your y's would be 3 plus 5 over 2. -2 plus 1 is -1, so it's going to be -1/2. 3 plus 5 is 8 over 2. It's going to give you 4. So my midpoint would look like this. The next example is similar, but not exact. Find the coordinates of B if M is the midpoint of AB. And they give the location of the midpoint, and they give the location of one of the endpoints, all right? So if you think about this one, we have our midpoint. They have given us the answer to the midpoint, and they've given us one of them. And so that means that this value right here is the average of the x's. And this value right here is the average of the y's. So that means -1 is going to equal -3 plus some x that we don't know divided by 2. Because it's the average of my x's and I only know one of my x's. All right. That means that my y for my midpoint, 1/2, is going to be that 4 plus some y that I don't know divided by 2. So in this case, they gave me the midpoint and one endpoint, and they want the other one. So instead of adding and dividing by 2, I'm going to multiply by 2 and subtract. So I'm just solving back into it. So for this, I'm going to multiply both sides by that 2. -2 equals -3 plus x. And then I'm going to add my 3 over. So x is going to equal 1. I'm going to multiply by 2. Multiply your midpoint by your 2. And then subtract the 1 value that you have. Subtract over, y is going to equal -3. And so the other endpoint that I'm looking for is located at 1, -3. That is my other endpoint. You can check it, right? You can say -3 plus 1 is -2 over 2, -1. Yes. 4 plus -3 is 1 over 2, 1/2. So you can check it and make sure that those two endpoints do give you the midpoint that you started with. All right? But when you are given an endpoint and a midpoint, you're going to be multiplying and subtracting instead of adding and dividing. You're just solving back into it. So we're building up to linear type equations and lines. One of the first things that you notice when you have a line is that it has a slope. So far we've compared different things with our x's and y's. We looked at the distance between your x's and y's. We looked at the halfway point or the midpoint between your x's and y's. And now we're going to look at the change between x's and your y's. And so your slope specifically is referred to as rise over run. How far you go up compared to how far you go over. So you're comparing your change in your y's to your change in your x's. And so in order to find the change, you are going to subtract. Now here, order matters because you have to do it in the same order with your y's and your x's, or you're going to flip-flop your signs, okay? And so the actual equation for this is y2 minus y1 over x2 minus x1. You do not put it into decimal form. You leave it in fraction form. You do not put it in mixed number form. So you leave it in improper fraction. You do reduce if you can, but leave it as an improper fraction. Now, what I will say is, if this is your x1, y1, and this is your x2, y2, then you're just going to subtract the y, subtract your x's. It actually doesn't matter which point is your first point or your second point. It matters that you keep it in the same order. So if I start with this y on top subtracted by this y, I have to start with this x on bottom subtracting this x. You have to subtract in the same order. All right? So let's look at this being used. They give 2 examples. The first one is a picture of a line. When you're given a picture of the line, find 2 points that cross exactly somewhere. Find 2 points that cross exactly somewhere. So like for this one, this particular line, I can see that it crosses perfectly right here. And what is that point? It's the y-intercept, but specifically what's the coordinates of the point?
0, 2.
And so then I want to look up and down this line until I see one that crosses exactly at another point. All right, so I wouldn't pick this guy here, or this guy, because you can see it's in between. I would pick one that is exactly on my coordinate here. So I am going to pick this one. And this one is for -1. I went over 4, down 1. Now, there's 2 ways to do it when you're given a line. You can use your slope formula. You can say, if this is x1 and y1, and this is x2 and y2, then you can say y2 minus y1 over x2 minus x1. All right? And you will get -1 minus 2 is -3. 4 minus 0 is 4. You will get that, right? You can also count, so you can walk your way from one point to the other. By that I mean you can start up here at your y value of 2, right? Y value of 2. And you can walk down 1, 2, 3 to get to this y value, right? So I go down 3 points. 1, 2, 3, down. If I move down, is it positive or negative? it's negative. So I went down 3. This is always my up and down movement, okay? And then from here, I walk over 1, 2, 3, 4. If I go right 4, is it positive or negative? It's positive. So you can see that when I plugged it into my formula or when I just walked it down and over, I got the same slope of -3/4. -3/4 is my slope, all right? -3/4 is my slope. The next way they gave it to us is just in coordinates, x1, y1. Again, it doesn't matter which is which as long as you do it in the same order. So if I put this in my formula, I'm going to say y2 minus y1. Watch your negatives. x2 minus x1. What is 2 minus a -4? 6, and 3 minus 1 is 2. I want to reduce this, so my slope here is going to be 3. All right? So always reduce it. Do not change it to a mixed number. Do not change it to a decimal, but always reduce it. Always reduce it. So they give you a couple of postulates here. Non-vertical lines are parallel if and only if they have equal slopes. Equal slopes. Any vertical lines are parallel. So if you have a vertical line, it's automatically going to be parallel. But if they're not vertical, you can tell if they are parallel because they will have the same slope. Their slopes will be equal if they are parallel. So parallel lines have equal slopes. Equal slopes. Non-vertical and non-horizontal lines are perpendicular if and only if the product of their slope is -1. The product of their slope is -1. Here's how you can tell if it's going to be -1. Another way to look at it is the slopes are going to be negative reciprocals of each other. Negative reciprocals. All right, which means the sign is going to change and you are going to flip it. So you will change the sign and flip it. Then it means it is perpendicular. Here, they will be equal. All right, so if you have equal slopes, they are going to be parallel lines. If your slopes are opposite sign and flipped, they are going to be perpendicular, meaning they will form right angles. All right, so let's look at these. This example that they've given us here, use the following points to determine if the lines are parallel, perpendicular, or neither. All right? And so they've given us the coordinates and they want us to check AB compared to CD. So we'll do that one first. So I need to find two different slopes. I need to find the slopes for AB and the slope for CD. And then I need to compare them. So for AB, I'm just going to do my slope formula. I'm going to say subtract my y's over subtracting my x's. So 4 minus 2, -3 minus 3. 4 minus 2 is 2. -3 minus 3 is -6. I'm going to get -1/3 for the line AB. All right? And then I'm going to do the same exact thing for CD. My y values, -4 minus a -3 over 1 minus a -2. -4 minus a -3 is -1. 1 minus a -2 is 3. Those are equal. So what type of lines do I have? have parallel lines. So I would say that AB is parallel to CD. Same slope, they're parallel. All right, let's look at the next one. A to E. So I'm going to take from A to E. So my Y values are going to be 4 minus 3 and negative 3 minus 0. 4 minus 3 is 1 over negative 3. B to C. My Y's are 2 minus a negative 4. 3 minus 1. 2 minus a negative 4 is 6. 3 minus 1 is 2. That is 3. So I have negative 1/3 and positive 3. What type of lines do I have? Perpendicular, right? My signs changed, negative to positive. And 1/3 when I flip it is 3. So for this one, I would say that AE is perpendicular. Looks like an upside down T to BC. Parallel versus perpendicular. That is how you tell. All right, that is how you tell. For the first one, A went down 5 and over 2. So you had a slope of negative 5/2. Line B went down 5 and over 2. And line C went down 9 and over 4. So from this, we should be able to say that A is parallel to B, but that's all we can say, right? Negative 9 over 4 does not reduce to negative 5/2. It is not parallel to the other two. So A and B are parallel. Let's look at the other one. So for line A here, it went down 3 and over 2. For line B, it went down 2 and over 3. What do we say about line A and B? They're perpendicular, negative reciprocals of each other, negative reciprocals of each other.